to... sorry, I'm mute. Okay. Welcome back to the next session. Now we have Luca Bianchi with us. He's a CTO at Neo Experience and an AWS Serverless hero. Luca is an experienced professional passionate about software architectures, serverless technologies, and machine learning. He has more than 15 years of experience, so he's very experienced on our AWS Serverless and all that. He will be speaking about serverless LLM. So welcome, Luca, on stage. I think I say it well, Luca Bianchi, right? It's right.
Yeah, that's perfect. You are one of the very few that can spell correctly my name. Everyone present me as Bianchi or Bianchi, but Bianchi is the correct one.
Yeah, that's my Duolingo sessions that works on Italian. So welcome, Luca. Tomorrow you will be hosting a track, so this is your moment to see how this goes. It's quite simple. I'm gonna share your screens. Share your screen. I have also a phone. Let me know if you want to share the phone later. Okay, I'm gonna share the slides now. All the floor is yours.
Welcome everyone to this session. It's a pleasure to be here and talk about two of my favorite topics, serverless and large language models. And we will see that we have a number of technology features that can join them together and could make you be able to write your next Gen AI app with basically no effort. But first of all, here is who am I? I am the right one, so the big one. The left one is my little daughter, and in my busy time, I am CTO at Neo Experience and a number of Neo Experience spin-offs, and I am proudly serverless hero since 2020. And I'm passionate about serverless and software architecture. Moreover, I'm one of the organizers of Serverless Italy, and by the way, Serverless Days next June, and Gen AI Milano Meetup. So I think that I am one of the very few people lucky enough to have put his hands on either serverless and event-driven architecture on one side and LLMs on the other side, and brought them into production. Right now, today, I want to tell you a story, and this story it starts as every story with once upon a time, and there was a simple LLM. LLM means that we had a large language models, which is a promising technology, because remember that a part of the huge number of applications that we see and POC that we see today, we are still at day one. We are still at the early beginning of this revolution. So we are still figuring out how to bring these LLM applications into production. The capability of these large language models, that they are called large because they have been trained on massive data sets, it is related that they are able to automatically learn and understand word and phrase relationships. So they are able to extract the semantic meaning of a phrase, of a paragraph, of a text, and store that meaning, and they are able to retrieve that bit of knowledge and use that bit of knowledge to generate a new text that it is resembled, it is in the same context of the input text. This means that this can open a very huge number of applications, because they have been proven to be able to be used to summarize text, to extract topics, to detect sentiment within a text, but also to customize messages. Think about landing pages, website landing pages customization, or knowledge retrieval. A lot of companies have a huge vast amount of knowledge that is usually unstructured knowledge. This is due to the fact that considering reports, really more than 70–80% of the internet, it is in the form of unstructured knowledge. and these applications are able to understand the meaning of that knowledge. They are not free from challenges. There are a few stuff that you need to face if you want to bring them into production, and but it is an exploding landscape. This is a picture that is just depicting the amount, the degree of availability of models that you actually have, just if you are looking to manage models. So you can use all these models with no need to be a data scientist, just invoking an API, just calling an API and passing the right prompt or the right data set to fine-tune the model. And it is massive. If you consider that just 2 years ago, there was nothing of them. We just had only GPT 3.5 released, and everyone was playing with ChatGPT. And now we have this vast amount of models. But even the application that we can have are challenging, because we have many many topics that needs to be orchestrated to build an LLM application. So just having a good LLM is not enough. This is due to the fact that we have a number of stuff. So we need to orchestrate the planning of information retrieval and prompt planning, prompt sending to LLM, but also we need to store the memory of previous interactions if we are providing a chat interface, and we need to store in some way the data context. We need to store the memory of the previous chats, and even be able to store in a suitable format the sentences that have been sent. Then we need to evaluate the models. We need to manage the prompts. We need to fine-tune prompts. We need to have something able to join all these pieces together with a bunch of traditional cloud infrastructure services, such as storage, such as databases, such as computing, in order to build a working LLM application. And here is where LangChain comes into the play. LangChain is an open source framework that it is actually more than 1 year old. It has been battle tested in a number of applications, even in production application, that made the platform, the framework, evolve, and they reached the 0.1 version. And now they are working actively on the 0.2, which will be the next major release of the framework, with a number of tweaks and improvements over the previous version. The idea of LangChain is to provide an abstraction on the different parts that make your application, and provide a standard and common interface in order to enable developer to just instantiate, say, an application with some kind of a model or prompt, and then be able to change the underlying model or the underlying prompt depending on your context, with no need to restart, to rebuild your application from scratch. This means that this could really empower the capabilities of developer in order to make them able to tackle the complexity of application. It is made of several parts. We have the LangChain core library, which is written in the supported languages, and LangChain supports either Python, which is the de facto standard language for machine learning and AI, but it also supports JavaScript and TypeScript. And it is much more important because the JavaScript support is an enabler to developers wanting to step into LangChain. Just let me clarify, LangChain is not a framework to train your model. It's a framework to use pre-trained model, deployed models, and a lot of the surrounding stuff for your application. And doing that with TypeScript, with JavaScript is great because it is the language of the web. So a lot of web developers are skilled using this language. And the LangChain core is the base framework. Then on that, we have LangChain templates, which are a collection of blueprints, so usable templates for different use cases that can consolidate the knowledge and the experience of other developers into reproducible use cases. Then we have two tools which are really interesting and are related to the managing and deploying of LangChain application. So just to be clear, they are external tools. They depend on LangChain, but LangChain is not dependent on them. So you can use LangChain in any configuration that we will be discussing about, that we will be seeing example of using LangChains. We don't need to use LangServer and LangSmith, but in some cases in which you don't have a cloud infrastructure at your fingertips to support you don't have an existing deployment strategy, using LangServe could be interesting, especially if you are a Python developer, in order to deploy LangChain chains. Application in LangChain are called chains because you tie together different modules, different steps within your application. And then LangSmith, it is a developer platform that can enable you to have monitoring, to have feedback collection, to have alarms, to have administration and playground and so on and so forth. So it is definitely something that you have to check out if you are not relying on existing cloud infrastructure. Then here we have the URLs for LangChain JavaScript and LangChain Python, and they point into the documentation. But let's see some code about that. This is a very simple code where I'm creating a chain. It is a simple chain that uses Llama 2 model, and it uses a construct provided by LangChain, which is the all-Llama construct, the all-Llama object that can be instantiated with Llama 2 model. And then I'm creating a prompt, and then I'm creating a chain. And as you see, the chain is the pipe of prompt, LLM, and the output. And then after that, I just only have to invoke on the chain with a given input, and I get an output. I'm using the Python code because it allows us to see clearly how the chain is built with no additional code. So it's perfectly clear to see how it works. But the nice part is that we can change the LLM variable. We can change the model with another model. We can change the prompt, or while we are providing data, we can use parametric prompts, and then we can read the prompts, say from a web page, from another a chart, or whatsoever, and that could be great. And the reason why it is so flexible is that it is built on the LangChain exponential language, which is a special purpose language which has been designed specifically to support parallel execution and retries and failbacks, and also getting intermediate results, so managing your pipe. So it is something which has been built specifically to support piping of different components. Then LangChain offers you a lot of model input outputs. So it enables to have prompt templates predefined for different use cases, or support to different LLMs, and then also have LLMs which can be one-shot used. So I need to summarize a test, so I'm sending the prompt, I'm sending the text, and then I'm getting back just one-shot response. Or chat models, which is an application of the same models that needs to be used in an interactive way. And then we have a capability, we have tools to parse and to customize the outputs. And then let me see with LangChain how it changes, how we can implement very easily something that is becoming quickly the new hello world for generative AI, which is retrieval augmented generation. RAG, for friends, RAG, it is a method or a way of using LLMs to retrieve knowledge from a vast knowledge base. So say I have the complete knowledge of my company, say I have the complete library of Wikipedia, and I want to make questions and extract information based on my questions from that vast amount of knowledge base. And of course, I cannot shrink all the knowledge base into a context. Even if I consider the most recent Google released model with a very huge context, it cannot host the whole content of Wikipedia. Then I need a retrieval mechanism in order to search a database of corpus of documents. I need a generative model in order to generate a response once that I found the meaningful pieces. And then I need a way of encoding that knowledge in order to make searches extremely fast. And I'm talking about semantic searches. So I want to extract pieces that have semantic meaning. And the other feature for RAG, interesting feature for RAG, is that the retrieval database can be updated, can be improved. And RAG can be summarized in these 4 steps: load, split, embed, and store. And load means that I need to pre-process the documents. I need to acquire source documents that can be from web crawling, data lake, or to proprietary database, and so on and so forth. I need to convert them from source formats, so standard PDF, docs, and whatsoever, to plain text. And then I need to chunk them. I need to split the text into smaller chunks, maybe with a few overlapping, because these RAGs works great on small chunks. And then the commands, the code to achieve that with LangChain is just 3 lines of code. And I'm using this sample, the Wikipedia page for the University of Pavia. I'm from Pavia, so I love Pavia and this university. I've studied there. And the most important part is that the model that I've been used, which is OpenAI GPT-4o, doesn't have the knowledge about this particular Wikipedia page. So it knows what University of Pavia is, but it doesn't know the details of that page, such as what did Leonardo study in Pavia, and so on. With just these 3 lines of code, we can load a new URL and then load a new document. Then after that, we have loaded the documents. We have the document object. Then I need to split the text. So I need to divide the text into correlated, syntactically correlated parts, such as phrases, paragraphs, sections. And we need to make that fit multiple relevant parts of the text in their chunks. And ideally, but it's something that's quite difficult to achieve right now, but ideally, one chunk should be associated with just one single topic in order to maximize the behavior of the RAG. So I need to divide the source text by phrases, paragraphs, and so on. And then I need to take a few engineering decisions. So the maximum size of chunks, so how long are the chunks, and whether to use overlapping between chunks. So do I need to have fewer redundancy between chunks or not? And then this takes me into defining this matrix. And it translates into just only 2 lines of code using LangChain, instantiating the recursive character text splitter, which is an utility provided by LangChain, and providing as a parameter chunk size and chunk overlap, and then invoking text splitter asking to split documents. So I don't have to integrate with the underlying splitter, I don't have to integrate with the function or routines needed to split a document. I don't need to orchestrate the splitting. I just have to invoke test splitter and ask for splitting the documents. Then the third step, it is embedding. And in the embeddings, we need to build a representation of the text in the form of numeric arrays, numeric vectors. And these vectors needs to capture the semantic meaning of words, which means that two semantically close terms needs to have numerically close values. So if I talk about students are visiting the city of Boston and my school is in Pavia, I expect that school and students are closer, they have numerically closer values than, say, school and Boston, as well. Boston and Pavia should have closer value than Pavia and the students. This is to the fact that semantically, cities and peoples are different partition of the language. Then I can use semantic similarity functions in order to find a compute similarity between words, and then I can use modern LLMs that leverage neural networks to represent model understanding of the text. And having a numerical representation means that I can make vector algebra works on the embeddings. So I can subtract that, I can compute the distance, and computing the distance, since that is a semantically meaningful distance, means computing the semantic distance between these terms. Then it can be used for semantic search, classification, clustering, etc. After that, I need to store these embeddings, which are huge vectors, somewhere. And a vector store is just a database which is specialized to handle vector data. So they can store huge number of huge vectors, so high-dimensional vectors, so that vector with a huge number of values that can be 1,000, 1,050, 36, and so on, or maybe more than 2,000 dimensions. And they should also provide an efficient way to compute that vector algebra in order to find similar vectors, and might scale up to billions of data points. So if you consider just one single Wikipedia page can be split into hundreds or thousands of chunks, and we are going to compute embeddings for each one of them, which means that we are going to store a really huge number of vectors. And they also need to index and implement fast retrieval, and they could have additional capabilities. There are a lot of open source and commercial vector stores, such as OpenSearch, Postgres with pgvector, Chroma, and so on, and also commercial one which Pinecone, the MongoDB Atlas, and even relational databases are providing vector extension. And this is translated into 4 more line of code, which is just using Pinecone, which is a commercial product. We just need to instantiate the Pinecone, provide the embedding model, which we are using OpenAI embeddings, and then just send the splits and send the embeddings to the vector store, and we are done. Then after that, once that a customer arrives, start typing in our chat and asking for a question to our knowledge base, we receive the text of the questions, and then we need to embed the text, and we need to search document using the embedded question, and which means that we need to find out and to extract the pieces in our knowledge base that is closer to that embeddings, and then we need to use the text belonging to that pieces of knowledge, fill that into the context, and then reply the question to the LLM in order to allow the LLM to generate a response, an answer to the user. And this stuff, it is done every time that I go back and forth with the LLM, with an additional point of complexity. I need to improve that stuff because I need to keep memory of previous conversation in order to keep the context. And this can be achieved, this is a completely different service, and this can be achieved using just a few lines of code, which is super easy. But now I want to explain how I can use this LangChain stuff to implement something that can be really fast to be released using Amazon Bedrock, which is a completely managed service. Amazon Bedrock provides a knowledge-based tool, which is a fully managed support for end-to-end RAG. So you can configure knowledge base, providing the vector store, providing the source, so the bucket, the S3 bucket that is related to document sources, and it allows, it automatically detects the availability of new documents, uses the embedding that you have selected to build embeddings, then uses the store that you have selected to store a vector within the database, and it is a completely managed service that you can configure from the console with just 3 steps. And you can also configure and invoke that using an API. So after that, you will have an endpoint that you can call just to perform all the RAG stuff. And it is super suitable for serverless, which means that we can use serverless to store documents, run LLMs, or inquire for LLMs, run queries against vector store, interact with users, and this could be great because providing a pay-as-you-go model allows for scalability and also having a cost-effective approach. Interaction can require many seconds because LLMs usually have a per second response time, but we can use serverless, which is intrinsically even driven in order to handle this asynchronous interaction. And just a very simple architecture that I would suggest you to consider for the RAG example, it is user that can upload file into S3 buckets, a Lambda function splits the data and then start the ingestion job, then ingestion tokens are set to OpenSearch, into open source service as a vector store, and then we have another Lambda that retrieve the knowledge. The best part of this story is that if we use Amazon knowledge base and if we use the library that I'm going to show you, all this stuff will be the point from number 2 to 8. They will be provided to you directly from Amazon knowledge bases. This is due to the fact that Amazon knowledge bases is able to orchestrate vector store, embedding models to generate and compute distance, and also provide an API for that. And then we can complement Bedrock knowledge bases with CDK for generative AI. AWS CDK is a framework, is a serverless framework to build infrastructure as code architectures, and it is super suitable for serverless because it can generate CloudFormation scripts to handle different stuff, different tools together. And AWS released CDK for generative AI at the last re:Invent, and they provide L3 construction, which means a high abstraction construct mapped to predefined use cases to implement regs. And now we are going to see how we can rewrite that previous example just using all the resources. So we can implement the architecture that we have seen just using the resources provided by CDK constructs. And as you can see, CDK Generative AI provides constructs to configure Pinecone within Bedrock knowledge bases, and then it provides the capability to configure Bedrock knowledge bases, providing the vector store, the embeddings model. Here we are using Titan Embed v1, and even the prompt, the instruction to configure that knowledge base and build the embeddings out from the documents. And then for the documents, we can create an S3 bucket, and then we can set that S3 bucket as data source with the tokens and the number of overlapping percentage that we want to provide. Moreover, we also can define the chunking strategy with whether we want fixed side or variable size chunks. And then we can also complement and extend this simple use case using the L3 constructs, which is already available within CDK Generative AI construct. And it is a construct that uses AWS AppSync in order to asynchronously manage a pipeline for data ingestion, and it is able to ingest data coming from PDFs or JPEGs, even images. This construct is super powerful because it can also index data coming from images, and it provides you an endpoint in which you use to upload the data into the ingestion pipeline that is stored in S3, and the data, the PDF, it is opened by the code, the Lambda function that under the hood they use LangChain in order to extract information from the PDFs. They implement a lot of chains in order to achieve that. And with images, they use recognition to extract metadata from images. And then all this information, it is stored, it is built as an embedding and stored within open source service. And to you that want to implement this use case, even with AppSync, which is a managed GraphQL, so even providing an API to your customer, to your end user, it is just as simple as instantiating one CDK construct, which is the reg AppSync step function open search. And you can also provide a Cognito user pool ID, which means that you can the access to these APIs, it's also controlled using user pool ID Cognito. And just instantiating that one, it makes you have available all these services, and all this code are already configured for you. Also, we also have another L3 construct, which is the Q&A, document Q&A construct. And it is again, an AppSync Q&A, an AppSync configuration using Lambda function for question answering, and leveraging on the same S3 OpenSearch and Bedrock services, powered by CloudWatch and X-Ray. And here again, to implement a Q&A service, so the other part of the architecture that we have seen before, it is just as easy as to build, to instantiate a new QA AppSync OpenSearch, providing here again a Cognito user pool for authentication. So they are extremely powerful. Even if you want to add a summarization step, if you want to have something using LLMs and using LangChain to summarize a text, you have a construct for that. And the same pipeline is orchestrated by this summarization AppSync step function, which is another construct that's available just to implement that one. And putting all together, we can build a complete solution for document exploring, document management, and we can build this complex architecture just joining these three constructs together in the same code base and have CDK generate the code and the infrastructure for us to implement this use case and to provide this use case to our customer. And so this was the final part of my presentation, and we have a few minutes for Q&A. So if you have questions, I'm here.
Thanks a lot, Luca. Super interesting. I'm gonna check if there's any questions in the meantime. But I'm gonna ask you something about this whole thing about LLM and actually the fun part is that I have origins in Papia. My grandfather was from there, so it's nice to see Pavia mentioned in a conference. This is something like, that's it makes everyone proud. Anyways, the situation with the open source models. Do you think that they have any chance to compete with the proprietary, like the ones that are Google developing and Meta and AWS developing, or it's something that we have the open source only for standards and to compete with them, for say, in a way?
That's a good question. I think that they have a reason to exist because actually we are moving from generic purpose LLMs to more tailored and specific kind of LLMs. So I would expect in the future that the battle won't be into having a faster or with longer context LLM compared to the vast amount of investment that has been done by cloud provider, but also we will face sooner, in a couple of months, the emergence of smaller models that can be suitable for embedding use cases that can be deployed to a smartphone. And in that case, being able to do a lot of research into the architecture of the model to have a clear understanding of how architecture works is something that could make a lot of research institutes work on them. And consider also that it is not a straight line between commercial and open source, because basically every provider, AWS, Google, and Microsoft, they are providing either a proprietary and open source managed version of these models. So I expect that there will be a lot of mix and matching in the future.
Okay. So you don't.
They are also financing. Yeah, they're also financing a lot of research projects. If you consider the most recent investment in LLMs, they have been funded by cloud vendors.
Yeah, that's true. Yeah, basically, just to give a little bit of context, because I know a little bit about the situation, the European Union is trying to not to control, to legislate, as usual. they are not allowing a lot of investment and a lot of innovation, but they are trying to legislate a little bit, and that's why mainly the point of the question. And also because I'm also involved in open source stuff, and I'm usually following that, and it's a little bit concerning that seeing that something that needs to be something as neutral as possible be managed by a couple of hands. That's
let me add another bit of information. There is a huge bonus point in open source LLMs, which is related to the fact that you can evaluate them. Model evaluation, it is something difficult. It can be done even for closed source, for proprietary models, but it is quite difficult because you don't know on which dataset they have been trained. You don't know. You have to trust the benchmark that are given you by the provider. With open source LLM, maybe you won't be building a new open source model, but you can evaluate them and you can have a clear leaderboard about which model works better on which tasks, which is something more difficult to achieve with proprietary LLMs.
Totally cool. Thanks for the clarification, Luca. Okay, I don't see too much movement on the chat. Looks like the people are a little bit shy. Still hasn't wake up in the European time. So thank you a lot, Luca. We are reaching the 40 minutes. So it's a 45-minute session. So we are closing now. Thank you a lot, Luca. Glad to meet you at least online, and hope to see you in another conference. And for the people that are still watching us, stay tuned, because we are continue right now. I'm going to say it in a right way. It's 11:55 Central European time, 12:55 for the people that are on the GMT +3. So stay tuned. We'll back shortly. Thank you. Bye-bye, Luca. Bye. Thanks.